Morning class, I'm Madam Chan here. Okay, today we are going to continue with the second subtopic of chapter 5, enlargement. Okay, before we continue with enlargement over here, you need to identify the meaning of, you need to know what is the meaning of similarity. Okay, if you look at the picture given, this is a picture of a house model, right? So can you identify what is the same and what is the different if we compare it to the actual house? Can, right? So if we compare to the actual house, actually the model over here has different size, but then the shape is totally the same as the actual house. Okay, we enter into the mind mobilization part to look into more detail about it, the meaning of similarity. So this part is for you to recognize the similarity of geometric objects. We have two triangles over here, triangle ABC and triangle PQR. So I'm just going to do part of it so that you can see and find out the meaning of similarity. So for example, angle A over here, I'm going to write angle A is the same as angle P. So I'm going to write down angle P right now here. And then angle B is the same as angle Q. Angle C is the same as angle R. So for angle P, it will be the same as the other way around, angle A, and the angle Q is angle B, angle R is angle C. So now for triangle ABC, we need to find the length of side. The length of sides for AB is 4. BC, if we look at diagonal, it consists of 3. The rest we are going to do it. Now we look at triangle PQR. Same thing over here. The PQ is equal to 8. QR is equal to 6. So when I convert them into the form of ratio, PQ over AB will be 8 over 4. And then QR over BC will be 6 over 3. So actually the answer is equal to 2, right? Okay, so I continue from the result that we found out. This one you are going to do it yourself. Okay, the two geometric objects are similar when all the corresponding angles are equal, which is angle A equal to angle P, angle B equal to angle Q, and angle C equal to angle R. And all the ratios of the corresponding sides are equal, which is PQ over AB, QR over BC, and RP over CA. So you got to remember this. The meaning of similarity over here, it comes when the correspondings are equal and only the ratios of the corresponding sides are equal. Okay, so now we look at the example given for the triangle here. Okay, you look at the smart tips. If all the corresponding sides of a pair of triangles are proportional, actually, the ratio must be proportional, then all the corresponding angles are equal and vice versa. So for example, if all the corresponding sides, this is 2, this is 1, this is 1, this is 2, this is 2, this is 1, for example. So when they are all proportional, meaning that all the corresponding angles are equal. Or it can be the other way around, when all the corresponding angles are equal, meaning that all the corresponding sides of a pair of triangles are proportional. Okay, are you okay with that? We move on to example 7 here. Determine whether each pair of the following geometric objects are similar. So we look at A. A is given a triangle over here. To find out whether they are similar or not, you need to compare the angle. 2 angles is already given. So to find out the other side, the sum of angle for triangle is 180, right? You minus 47 minus 79, we will get a 54 for this one. So 54 is the same as this angle over here. Therefore, these objects are similar. Okay, then we look at B. If B, you compare all the angle, 120, 120, this is the same as this one, 100, 100. So meaning that the angles are the same. Okay, but then we have to find the corresponding side, the ratio of the corresponding side. So for example, I'm finding AB. AB corresponds with which side? Can you identify it? It's actually PQ, right? AB with PQ. So 9 over 7.2, you got to find out the answer. And then for AE is 8. AE is equal to PT. So 8 over 6.4, we find out the answer. And then this side is 10, this is 8. So 10 divided by 8, we get the answer. Okay, as you found in the answer of your book, all of it is equal to 5 over 4, 5 over 4, 5 over 4. So meaning that the ratio of the corresponding sides are equal. Okay, therefore, this geometric object are also similar. Okay, now if you look at C, we have A, B, C, D. This is a square, right? With a measurement of 6, 6, 6, 6, all of it. But then when it comes to P, Q, R, S over here, the measurement is already different. So for sure, this one is not similar. Okay? Okay, now we are going to look at the relationship between similarity and enlargement and how to describe enlargement. So from this activity over here that you have in your book, they ask you to observe. After that, you have to connect all the corresponding point of all the images and then mark the intersection point between the three straight line as point P. So we are going to join all the vertices together. So we will have a line like this. Therefore, the intersection point over here, it is point P. Okay, so from the finding, I'm not going to do this together with you, so we're just going directly into the finding over here. So the finding is the result from that mind mobilization. It shows that object and image under enlargement are similar. Okay, remember this, object and image under an enlargement are similar. Similar meanings they are having the same shape, and then the ratio of the length of the sides are the same. So look at this paragraph. Enlargement is a transformation in which all the points of an object move from a fixed point with a constant ratio. The fixed point is known as the center of enlargement. So this is the center of enlargement. And the constant ratio is known as the scale factor. So this part over here, the ratio meaning that from P to A prime, PA prime over P to A is equal to scale factor K. Okay, we will look into this later on. So let's go to the next page. Okay, so in general, we can see that the scale factor, this one, the K is equal to the distance of point of image from P. So point of image, this is the one, because this is the image. Okay, the distance of point of image from P, this is the one, over the distance of point of object from P. So this is the object, is over this part over here. Whereas it also can be determined as K is equal to the length of side of image. So either one, you have to find the corresponding side. For example, this one is the one that I want, over the length of the object. So it must be the side that is correspond. Okay, now we look at the table given. Different scale factors have different effects on enlargements. So if you look at this part over here, the first column, the scale factor K, we have K is greater than 1. Then the size of the image will be larger than the object. So you can see this is how it looks like. Okay, when the K is equal to 1, the size of the object is the same as the size of the image. So this is the one. And then when it is in between 0 and 1, for example, it is 0.2 or 0.3, or it can be 1/2, then the size of the image will be smaller. So you can see the image over here, it is smaller. And then when it comes to this range, it is also smaller. Okay, why? Because the value of K over here, you can determine when it is -1/3. -1/3 meaning that it's in between -1 and 0, right? Or -1/2 also can. So when it comes to -1, it will be on the opposite side. So it will be opposite like this. This is the object, it will be opposite here. This is the image. Okay, so when it is less than -1, the size of its image will be larger than the object, and then it will be the opposite side of the object. So you can see the object right now here, it will be the opposite side of the object, and then it will be larger than the object. So how do we memorize all of this? It seems a bit difficult, right? No problem, I let you know. For example, this one. K is in between 0 and 1. So 0 and 1 like this, meaning that this is the range. For this one, the range is in between 0 and -1. So the range is also here. Okay, when I combine everything, you are going to see the difference easily. Okay, I'm going to start with 0, and then we have -1 here, and then we have a 1 on the right. So when the range is in between this, which is in between -1 until 1, from here to here, meaning that you can see the image are smaller. So this part, it will be smaller. When it comes to greater than 1 and less than -1, this part over here, okay, and greater than 1, it will become larger. So you can see larger. So this part, larger, larger. When it is equal to 1 or negative 1, then you will know it is equal in size. Okay, so you just have to memorize this number line right here. When it is less than negative 1 or greater than 1, it will be larger. When it is in between this range, the image will be smaller. Okay, so you bear in mind now, we are going to use this to go through example 8 and so on later on. Okay? Okay, now look at example 8 over here. The diagram on the right shows 3 objects and their images under the transformation of enlargement. Describe the enlargement by determining the scale factor in the center of enlargement for the following. So what do you need to do is describe the enlargement over here, okay, and then you need to determine the scale factor in the center of enlargement. So you got to bear in mind when you describe an enlargement, what do you need to state is the center of enlargement and also the scale factor, these two. So before we describe the enlargement, we need to find the scale factor. Now we look at the first object over here. We have 3 objects. So object ABC is the one in the middle over here. Okay, so to find out the scale factor, it might be easy for you. So what you need to do is you just need to find the distance from A prime to B prime. So for example over here, from A prime to B prime, you can see how much is the distance. Okay, this is I use highlighter. 1. Oh, it's not clear. Let me change it. So we use a different color. Okay, which one can find it easily? Okay, green. So this is 1, 2, 3, 4, 5, 6. 6 boxes, and then for A to B will be 1, 2, 3, 4. Okay, therefore we can write down already for the scale factor for A. I write on here, scale factor is equal to A prime B prime over AB. So the A prime B prime just now is equal to 6, and then the AB is equal to 4. Therefore, after you simplified it, it becomes 3 over 2. So when you look at 3 over 2 over here, you still remember that I asked you to compare using the number line to determine whether it is bigger or smaller. So this is -1, 0, 1. Okay, 3 over 2, where is 3 over 2? 3 over 2 is actually a 1 over 2, right? Which is greater than 1. Meaning that the image is larger than the object. So it is proven already over here. You can look at the image, which is A prime, B prime, C prime. It is larger than the object of ABC. So over here, after we found out the scale factor, what you need to do is you need to find the center of the enlargement. So to find the center of an enlargement, what you need to do is by using a ruler, you need to join up all the corresponding points. So we join up all the corresponding points first. I'm going to use a smaller size. Okay, so join the corresponding point, this one to this one. Okay, and then the A with A prime, this with this, something like this, and then B with B prime. So make sure you join up correctly, Mine is not very clear over here. Okay, so when I join up everything, it actually falls on this point. Okay, can you find out what is the coordinate for this point? If this is -5, so we have 1, 2, 3, 4, 5, meaning that this is a -2 over here. And then for the x will also be the same. This is -4, -3, -2. So the coordinate that we found out for this one is actually -2. Oh, sorry. This is not -2. This part here is less than -2, so it's supposed to be -1. Okay, so -2, -1. Okay, so we found the center of the enlargement already. Therefore, we can continue with our description over here, how to describe the enlargement. So remember, to describe the enlargement, you are going to describe the scale factor and also the center of enlargement. So for the answer for A over there, the A prime, B prime, C prime, you have to find out the image, is the image of what? Image of object ABC. Okay, it's the image of ABC under what? Under the enlargement. So you follow all this word under enlargement at center. The center that we found out just now is -2, -1 with scale factor of, so you just follow this, 3/2. You don't simplify, it becomes a mixed number. We just carry on with the scale factor that we have. Okay, so for the first one, it's done. Okay, we continue with B, which is the object RSTU. Okay, so for object RSTU, if we have joined up all the corresponding vertices, we will see something like this. It's in your book. So actually, all of you have to join up using the dotted line, not the solid line. So after we join up RSTU with R prime, S prime, T prime, U prime, the smaller one over here, make sure you join with the corresponding vertex. So we will find the point. Okay, this is the center of enlargement, that is 13, 10. So you just need to refer to your coordinate over here. It is 13, and then this one is a 10. So you found the center of enlargement already. Now we need to find the scale factor. So it's easier for you to find the scale factor from the horizontal line or the vertical line. So the horizontal line that we have over here is this UR. So we are going to compare this. Okay, so for B, find the scale factor. Scale factor is always the length of image over the length of object, or it can be the distance from the image to the distance over the distance of the object. So over here, we are going to use R prime, U prime over RU. Okay, so R prime, U prime, this one you can see, okay, it just consists of one box over there. Okay, over the RU, we have 1, 2, 3 boxes over there. So directly we got the scale factor, which is 1/3 already. Okay, then you can describe your enlargement. So R prime, S prime, T prime, U prime, okay, is the image is the image under an enlargement. We need to get used to this word. Is the image under an enlargement. At what? At the center of, at center 13, 10 with a scale factor of 1/3. So you just remember, whenever you want to describe an enlargement, just make sure you need to describe the center and also the scale factor. Okay, and also from the scale factor, we can also check the scale factor is 1/3, right? Where is the range of 1/3? Okay, let us look at the range. Okay, I redraw again the range of 0, -1, and 1. So 1/3, it is right here, right? So you remember, from this range to this range, the image is actually smaller. So you can check whether the answer is correct or not. The image is smaller. Yes, it is. And the object is bigger. So this is the object. Okay, now we move to C. So same thing, we are going to find the scale factor. So for C over here, after you join the corresponding vertices, you are going to get the center of enlargement over here, which is 2, -5. So the next thing, we are going to find the scale factor. The scale factor is the length of the image over the length of the object. But over here, we don't have a vertical length or a horizontal length as what we have earlier. Like this one, we have horizontal length, so it's easier for us to identify. But right now, we cannot identify from the horizontal and also the vertical length. Therefore, what you can do is you are going to get the distance from the center of the enlargement. So scale factor is the distance from the center of the enlargement to the image. We get the one to the image first, the one that we can find. Okay, so distance of which one from the center will be easier? This one, right? So that you can get a horizontal line. If this one is harder for you to get the answer unless you use ruler, but ruler will be tedious. So over here, from the center of the enlargement to point L, we can determine the number of boxes, which is 1, 2, 3, 4, 5, 6. So from the center of enlargement, PL prime over PL, it is equal to 6 over, and then now we look at PL, 1, 2, 3. So it is 6 over 3. The answer is equal to 2. But then you don't forget one thing. If this is the object and the image is in the opposite side, okay, it doesn't align to the right or to the left, right? So it is the opposite side, meaning that you have to add on a negative sign for this. Okay, so now we can describe the enlargement already. So this figure over here, the image, the L prime, M prime, N prime is the image of L, M, N under an enlargement at center. Where is the center? The center is 2, -5 with a scale factor of the one that we found out just now, -2. Okay, so from the scale factor -2 also you can check whether we got it right or not from the number line. So again, you can check from here, 0, -1, is a +1. Okay, so the number that we have is -2, right? -2 is over here, meaning that the image will be bigger. So it's correct, right? The image here is bigger than the object. Okay, now we are going to learn how to determine the image and object of an enlargement. So you can look at the flowchart given down here. There are 4 steps. The first one is to identify the center of enlargement. Second is to identify the scale factor. And then after that, you draw the projection line from the center of enlargement to each of the vertex. And then lastly, you draw the image or the object which has the similar shape according to the scale factor. So first 2 things, same thing over here. You have to identify the center of enlargement and also the scale factor, just like how you learn to describe the description for the enlargement. So now we look at example 9 given over here. Based on the given scale factor, determine the object and image for each of the following enlargement. So we need to determine the object and also the image for the given enlargement. So for the first question A over here, the scale factor is already given, which is 2/3. So from the scale factor, we are able to determine the image or the object based on the number line that we have learned, right? So if you have memorized properly, you don't have to always draw this out. But then if you can't, then no choice. So K is equal to 2/3, it falls on this part, which means the image is smaller than the object, right? So over here for the first question, to find the image that is smaller, B is smaller, therefore B is the image, and then A is the object. Okay, so you can look at the solution given down here. When K equal to 2/3, size of image is smaller, and then the object. So A is the object and B is the image. Okay, now we look at question B here. The scale factor given is equal to -1.5. So if it is given -1.5, it falls on the number line on this part here. So we know that the image will be larger. Okay, so from here, S is larger, meaning that S is the image, and then R will be the object. So you can refer to the solution given for B. When K equal to 1.5, -1.5, size of image is larger than the object. So R is the object and S is the image. Okay, look at example 10. Draw the image for each of the following objects using P as the center of enlargement for the following scale factors. So P is given down here. Okay, and then scale factor is 2, if the scale factor is 2, meaning that the image will be larger than the object. So the next thing that we need to do is to draw the line from the center of enlargement to each of the vertex. We are going to join them up. So I draw the first line here. Okay, this is the first vertex, followed by the second. Second is, okay, this one here. Okay, the next one is this one here. Okay, so we have all the line already. Actually, you have to draw using the dotted line. So after that, because over here, if k is given equal to 2, meaning that the image is larger, right? So the one that given over here is the object. Okay, so what you need to do is you need to find the distance, because you're given the k already. K is equal to the distance of the image over the distance of the object. Hope you still remember image distance over the object distance. Okay, this one just for you to recall back. So from the distance over here, we are going to look at the one which is horizontal over here. 1, 2, meaning that it is 2 units, right? When the k is equal to 2, meaning we are going to multiply by 2 to get the image distance. Okay, so 2 times the k of 2, which will be 4. So I have to move 2 more places to the back. So this is the first point. Okay, after that, for the second one, we look horizontally. Vertically. So vertically over here, we have two parts, right? Same thing, multiply by 2. So we are going to get a 4. This is the place. I make it using a darker answer here. Okay, and then for the this one, which is crossing, not very diagonally, but we can count also. So you just need to calculate the number of distance horizontally and vertically. So you can see this is a box, right? So to get the point, we have 2 boxes and also 4. So it is 2 times 4. Double up, you are going to get 4 times 8. So from there, I'm going to move up 8 boxes. So this is already 4, 5, 6, 7, 8, and then this is 1, 2, 3, 4. So the next point that we can get is over here. Okay, then lastly, this vertex over here, to identify it, you can get the distance horizontally is 1 times 2, right? So it will be 2 times 4. This will be the point. So then you just join it up using your ruler, like this. Then you get the next the image already. Okay, now we look at the second question here. When k is equal to -3/4, which means the image will be smaller. So when the image is smaller, first you need to find out the joining from the center of enlargement to all the vertices. Okay, so I'm going to draw the line as usual. You draw the line. Okay, first line done. Second line is here. Up a bit. My hand is shaking. Okay, so our line is done already. How to determine? To determine it is a bit I changed the color. This color just for you to determine, but then you don't do the sketches. So when k is -3/4, we are going to find, for me, I'm going to find the horizontal line, which is easier for me. So I'm going to use the k is equal to the distance of the image from the center of enlargement to the image, okay, to the object, sorry. So this is what I'm going to use, 1, 2, 3, 4. Okay, so originally the object is 4. 4 times the value of k, which is 3/4, I'm going to get a 3. And then when it comes to negative, meaning that the image is opposite the object. So it will be 3 boxes opposite the object. Therefore, I'm going to move 1, 2, 3 to the right to get the line. So the line over here, it will be this line. Okay, I'm going to draw using black color because 3. Okay, done. So next one. To get the rest, you can see the distance over here, the horizontal distance is 1, 2, 3, 4. Also 4. 4 times 3 over 4, we are going to get 3. So 1, 2, 3, you just draw the line. Okay, so I'm going to use black also. Make sure you can draw your image clearly. Now, lastly, what you need to do, just join them up. Join them up. And the other side. Make sure you don't extend, make sure your line doesn't extend. Okay, draw properly. Okay, so we've got the image for the object already. So now we are going to learn the next one, which is you are going to find the object. This one is for you to find the image, right? But then the next example, you are going to learn to find the object. So we look at example 11. Okay, this is the one, example 11. Draw the object. Okay, remember the object. For each of the following images using P as the center of enlargement for the following scale factors. So you're given a scale factor of 1 over 2. If the scale factor is given 1 over 2, okay, let us referring to the number line again. Referring to the image. Can you tell me whether the image is bigger or smaller? The image, if K is 1 over 2, it falls over here, right? Meaning that the image is smaller. The image is smaller. So now you are given the image, but then you were asked to draw the object. So for sure, the object will be the opposite way. You are going to draw the object bigger or larger. Okay, same thing, we check for the next one first. When K is equal to -3, meaning that it falls over here. So the image will be larger. Okay, so the image given is larger, meaning that you have to draw the one, the object will be smaller. Okay, so first of all, same thing, you are going to join all the vertices to the center of enlargement. Okay, I'm going to pause for a while so that I can join first, then later on we continue after I finish up all the joining. Okay, so I've joined up everything as you can see over here. Okay, now we are going to identify the each of the vertex for the object. Okay, first one that I'm going to identify is this point right here. Okay, so what can I do is, because of the distance is about 2 boxes. You can see 2 boxes horizontally. So I'm going to move it, becomes 2 times 2, which is 4. So 1, 2, 3, 4. Okay, can you see? It falls right here. This is the first point to represent it. Okay, followed by that, then we can count. For the horizontal line over here, we have 1, 2, 3, 4. So 4 times 2 again, it becomes 8. Therefore, I'm going to move 1, 2, 3, 4, 5, 6, 7, 8. This is the next point. Okay, after that, here we have 3, right? So I'm going to move up, becomes 6. 1, 2, 3, 4, 5, 6. This is the point. And then for this point, so you can see, same thing, it is 3. So I'm going to move up 6. 1, 2, 3, 4, 5, 6. It will fall on the line that we draw earlier. Okay, and then in between the box over here, it is 2 lines connected. It's a line connected with 2 boxes, right? So we just need to continue with that boxes that we have. Okay, it becomes 1, 2, 2 over here, or you can use the distance from the P. Okay, I'm going to move up until this point. Okay, so after that, what you need to do is you just need to join them up using your ruler. Don't do like me because I need to make it fast to let you see. So just join up all the vertices together. Okay, So that is how to get the object. Now we look at the other one for B. So same thing, I'm going to draw the line first. You give me some time, so I'll come back to you later on. Okay, I'm done with it. So we just continue to draw the object. Okay, bear in mind again, if the scale factor is -3, meaning that the image is bigger. So when you have to find the object, you have to divide by 3. It's the other way around. Like just now for A, if it is 1/2, then we multiply by 2 to get the object. So first I'm going to look for the distance. Okay, the distance, horizontal distance from the straight line of the figure, this straight line over here, we are going to find out. It is 1, 2, 3, 4, 5, 6. So 6 divided by 3, I'm going to get a 2, meaning that the horizontal distance from there is 2. Okay, then I can draw my line already. Okay, but then you count before that. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 divided by 3, we are going to get 6, right? 9 divided by 3, we are going to get 3, meaning that the distance or the vertical distance for that image is 3. So in this part here, we can draw the straight line already, but then you got to know it is 3. So we use this and the end of it as the point, okay, until here. Okay, now we can look at the horizontal line. This is 1, 2, 3, 4, 5, 6. 6 divided by 3 is 2, right? So we are going to draw 2 boxes to the left here. So you can see it falls on this line, this vertex falls on this line. We have 3 already, so we just extend the one on top. It will be the same because it's the rectangle. So lastly, you just cross the line and draw it. Okay, so we have done this part on how to draw the object already. That's all for today. We are going to continue with the next one in the next lesson. Okay, see you. Bye.